Hi netizens, quick one. Integration. We understand that integration is the reverse of what? Differentiation. Sorry, my microphone is bad. Let's manage it for the time being. Um, I'm to evaluate integral of x times into brackets x squared plus 1 all raised to power 5 dx. We need to look at this question critically, then know the right approach. Which rule do we use? Do we need the general method? Do we need substitution? If you look at this houses different words, values in the context. So I'm going to use the method of substitution. Now we can say let u be equal to whatever we have in this function, x squared plus 1. If u is x squared plus 1, then what we get as du? Actually, du can be 2x dx. What this simply means is to get the derivative of x squared plus 1. The derivative of x squared plus 1 is what? 2x then dx. How did we achieve that? When this is differentiated with respect to x, we get, if you differentiate this x squared, you'll be getting this power comes as the coefficient, which is what? 2x. Then you take 1 out of this, what? 2 as the exponent, you get what? 1. Of course, we still have it this way. So whenever you differentiate a constant, of course it is what? 0. So we can say that du is what? Equal to 2x dx. So that is the derivative of what? X squared plus 1. That is not the end. We can also divide both sides by 2. If we do that, we'll be having du over 2, which is something as what? Half du, which is equal to what? X dx. We've achieved what we want. So at this point, anywhere we come across x squared plus 1, it becomes what? U. Whenever we come across x dx, we get what? Half du. So with this, we can easily integrate. So this becomes integral of, remember what this is at the moment, x squared plus 1 is now what? U. So that is what we have. So we'll be having u. But of course, this value has the exponent as what? 5. So we are going to plug in 5. Do you understand that? So we proceed. Remember, x dx is something as this x dx. And what does it give us? We are having half du. So this becomes times. Remember, this means times, not decimal. Decimal comes somewhere here. So, but when you indicate a point in the middle, it becomes what? Multiplication. So this becomes u raised to power 5 times half du. Then we need to proceed. Whenever we have something of this nature, then we need to bring out the constant to be in front of the integral symbol. So it becomes its what? Coefficient. So in other words, I'll be having half integral of what? U raised to power 5 du. So you can see what we have come to achieve. So to proceed, we also need to think of how we can actually do what? Integrate this. So this has actually aligned the way we can easily integrate it. So to integrate this, we'll be having 1 over 2, which is half. Remember, whenever you're integrating, this integral symbol will not be needed anymore. So this becomes half times, what do you have here? When we integrate this is exponent what? 5. We add 1 to it. This becomes u raised to power 5 plus 1. Then over the result of the new exponent. That will be what? 5 plus 1. Remember, we need to add our what? Constants. Okay, so that is what we have as a what? Integration constants. Then if we do that, what do we achieve? This becomes, sorry, half times 5 plus 1 is what? 6. This becomes u raised to power 6 over 5 plus 1 is of course 6. Then plus what? The constant of integration. So what do we do at this point? Of course, 2 times 6 will give us what? 12. We're having 1 times u raised to power 6 is still what? U raised to power 6 over 2 times 6, which is what? 12. Then plus what? The constant of integration. Of course, this would have been the final answer. But remember, initially we are having values as what? X. And this x was being what? Substituted. So we need to plug in the x back to the function. So we say that u is what? X squared plus 1. So what we have here, we're having u raised to power 6. So that becomes x squared plus 1. Now this is the new exponent. Then raised to power 6 over what? 12. Then plus what? The constant of integration. This becomes our final answer. Bye bye. Please like, share, and what? Comment. Bye bye.